October 25, 1944, 3:47 p.m. 17 miles off the coast of Samar Island, Philippines. Lieutenant Commander Takeshi Yamamoto clung to a piece of floating debris that had 23 minutes earlier been part of the heavy cruiser Chokai's forward superstructure. The water around him was on fire. Oil burned in patches across the surface, creating walls of flame that shifted with the current. Through the smoke, he watched something that made him question his sanity. A single American battleship, hull number 61 painted in letters taller than a man, fired 9 massive guns simultaneously. The muzzle flash lit up the entire ship like a camera bulb. The sound arrived 3 seconds later, a thunderclap that seemed to come from inside his chest. Then came the shells. Before we continue with Commander Yamamoto's incredible story, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now back to the Philippine Sea, where Commander Yamamoto was about to witness what Japanese naval doctrine said was impossible. 9 shells, each one weighing 700 pounds, all airborne at exactly the same moment, traveling at 690 feet per second toward what remained of the Japanese center force. Yamamoto had graduated from the Imperial Japanese Naval Academy at Etajima in 1936, ranking 14th in his class of 178. He'd been taught that battleships fired 1 turret at a time to maintain stability. That simultaneous discharge of all main batteries would snap a ship's keel, that American industrial might was propaganda designed to weaken Japanese fighting spirit. He'd believed it all. Now he watched the USS Iowa, all 887 feet and 58.00 tons of her, absorb a recoil force of 318 tons without even listing. The ship didn't break apart. The hull didn't buckle. The Iowa simply sat there in the water, steady as a mountain, and prepared to fire again. The shells hit the already crippled heavy cruiser, Kumano, 47 seconds later. Yamamoto knew Kumano's captain, Hitomi Soichiro. They'd served together on the destroyer Akebono in 1938. Hitomi had a wife in Kobe and 2 daughters he carried photos of in his breast pocket. The older girl, Yuki, wanted to be a teacher. The younger one, Akane, was afraid of thunderstorms. The first shell went through Kumano's forward magazine without exploding. A 700-pound solid metal cylinder, traveling faster than sound, punching a hole you could drive a truck through. The second shell hit the base of the forward turret and detonated. The explosion was so powerful, it lifted the entire 900-ton turret assembly 15 feet into the air. It came down tilted at a 40-degree angle, crushing the deck beneath it like cardboard. The 3rd through 9th shells simply erased the ship's midsection. One moment Kumano was there, 512 feet of steel and 100 men. The next moment the bow and stern were 2 separate pieces, held together by nothing but burning oil and sinking fast. Total elapsed time from impact to complete hull separation. 11 seconds. Yamamoto never saw Hitomi again. Between October 24th and October 26, 1944, during the Battle of Leyte Gulf, the Imperial Japanese Navy lost 28 ships, 3 battleships, 4 carriers, 10 cruisers, 11 destroyers. Total personnel, 500 men dead or missing. All of them had been taught the same naval doctrine Yamamoto learned at Etajima. All of them believed that Japanese night-fighting superiority, long-lance torpedoes and Bushido spirit would overcome American material advantage. None of them had trained to face the Iowa-class battleships. The problem wasn't American numbers. Japan had anticipated that. The problem wasn't American air superiority. Japanese commanders had planned for it. The problem was that American battleships could put 9 shells on target from 23 miles away with targeting precision that seemed supernatural, and they could do it every 40 seconds, all day long, without stopping. Hitomi had mentioned it 3 weeks earlier. over sake in Chokai's wardroom. I heard the Americans have a new fire control system. Rumor says it uses electrical calculating machines. Propaganda, Yamamoto had replied. Machines can't calculate ballistic trajectories in real time. You need human rangefinders with years of training. Hitomi had smiled, but it hadn't reached his eyes. The Americans lost 2 destroyers last month. 0 survivors. What if the propaganda is true? Now Yamamoto floated in burning water, watching that propaganda destroy what remained of the center force. The USS Iowa had been commissioned on February 22, 1943, at the New York Naval Shipyard. Her construction required 20 Iwosern workers, 19 months, and $100 million, roughly $1. $7 billion in today's money. She carried 9 16-inch 50-caliber Mark 7 guns, arranged in 3 triple turrets. Each gun was 66 feet long and weighed 239 zoazeron pounds. But the guns weren't the innovation. The Mark 38 gunfire control system was the innovation. It occupied 3 levels inside the ship's armored citadel. The brain of the system was a Mark 8 Rangekeeper, an analog computer weighing 500 pounds, containing 150 precision gears, cams, and differentials. It received continuous input from Mark 8 radar ranging system, accurate to 50 yards at 20 miles. 2. Mark 40 optical rangefinders, each 46 feet long. Mark 41 ballistic computer, calculating wind, temperature, air density, earth rotation. Stable vertical reference system, compensating for ship pitch and roll. Target bearing and course tracking system. The Rangekeeper updated firing solutions 30 times per second. A human naval gunnery officer with a stopwatch and slide rule needed 8 to 12 minutes to calculate a single firing solution. The Mark 38 system did it in 7 seconds, continuously, automatically, while tracking up to 6 separate targets simultaneously, and it could coordinate all 9 main battery guns to fire as a single broadside, something Japanese naval doctrine declared structurally impossible. The system had one weakness. It required 400 kilowatts of electrical power to operate. The Iowa had 8 turboelectric generators producing 10 Ruwezern kilowatts total. American industrial capacity made that possible. Japanese shipyards couldn't spare the copper wiring. Lieutenant David Morrison from Tacoma, Washington, was the fire control officer who put those 9 shells into Kumano. He was 26 years old, a former Boeing engineering apprentice who'd enlisted 3 days after Pearl Harbor. He'd scored perfect marks in mathematics at the Naval Academy and could calculate azimuth corrections in his head faster than most men could use a slide rule. Morrison sat in the Mark 38 plotting room, 3 decks below the main deck, surrounded by humming machinery and men reading dials. The air smelled like electrical ozone and machine oil. The temperature was 87 degrees Fahrenheit, despite ventilation fans running full blast. Target bearing 317, range 21,000 yards, course 1905, speed 18 knots, the radar operator called out. Morrison watched the mechanical solution form in real time on the Rangekeeper's output dials. Elevation 18, 4 degrees. Azimuth 317, 2 degrees. Time of flight 46, 8 seconds. Predicted impact point 200 yards ahead of target's current position. Solution locked, Morrison said. Broadside, all turrets, Chi shells. Broadside ready, came the reply from Turret Captain Chief Petty Officer James Chen in Turret 2. Chen was from San Francisco's Chinatown. He and Morrison had joined up the same week. They'd planned to open an auto repair shop after the war. Morrison and Chen's automotive service, 50-50 partners. They'd shaken hands on it during boot camp, promised to survive long enough to make it real. Fire, Morrison said. The ship shuddered. Not violently, more like a deep visceral pulse that ran through every frame and rivet. The recoil from 9 16-inch guns firing simultaneously generated 318 tons of backward thrust. The Iowa's designers had calculated every pound of that force and engineered solutions. Hydraulic recoil buffers that absorbed 80% of the shock, a hull structure with longitudinal strength bulkheads, and a displacement weight heavy enough to maintain stability. What the Japanese thought would break American ships in half barely made them lean. Splash in 46 seconds, Morrison noted, watching the chronometer. The Mark 8 radar tracked the shell flight. The system could see the projectiles as they traveled, tiny dots on the radar scope following the ballistic arc, exactly as predicted. 46.3 seconds later, the radar showed 9 impacts clustered within a 150-yard circle around the target. The predicted dispersion for that range was 220 yards. They'd beaten the margin by a third. "Target destroyed," the radar operator reported. "Hull breaking up. She's going down." Morrison marked it in the log. October 25, 1944, 15:47. Target, heavy cruiser, Mogami class. Range, 21,000 yards. Result, destroyed. 9-shell broadside, he didn't know the ship's name was Kumano. Didn't know Captain Hitomi Soichiro was aboard. Didn't know about the photos in Hitomi's pocket or the 2 daughters in Kobe. He just knew the mathematics worked perfectly. Chen's voice came through the intercom. "Turret 2 ready for next firing sequence." "Stand by," Morrison replied. That night, after the battle, Morrison and Chen met in the crew mess. The compartment smelled like coffee and cigarette smoke. Most of the men were too wired to sleep. Some wrote letters home. Others played cards with shaking hands. "You ever think about them?" Chen asked quietly. "The guys on those ships?" Morrison looked at his coffee. It had gone cold. "Can't afford to. We think about them. We hesitate. We hesitate. They hit us instead." "Yeah." Chen lit a cigarette. "Yeah, you're right." "Still opening that garage?" Morrison asked. "Damn right we are. Morrison and Chen's. Best auto shop in Tacoma." They shook hands again. Same promise, same partnership. Chen died 9 days later, November 3, 1944. The Iowa was providing fire support for troops on Leyte Island, a Japanese bomber, a Mitsubishi G4M. What the Americans called a Betty came in low and fast during evening twilight. The ship's 5-inch anti-aircraft batteries opened up, but the plane was already too close. The bomber hit the water 30 yards from the Iowa's starboard side and exploded. Shrapnel tore through the 5-inch gun mounts. Chief Petty Officer James Chen was training Gun Mount 7's crew when a piece of the bomber's engine, superheated and traveling at 300 feet per second, went through his chest. He was dead before the corpsman reached him. Morrison was in the fire control room when he heard. He marked it in his personal log, the one he wasn't required to keep but did anyway. November 3, 1944, 18:23. CPO James Chen, Turret 2, KIA. "We were supposed to open a shop together. Then he went back to calculating firing solutions because there were more Japanese ships out there, and hesitation got Americans hurt. Between October 1944 and August 1945, the 4 Iowa-class battleships, Iowa, New Jersey, Missouri, and Wisconsin, fired approximately 21 Uro 16-inch shells in combat. They participated in every major Pacific operation, from Leyte Gulf to the bombardment of the Japanese home islands. Total Iowa-class losses to enemy action, 0. Not one Iowa-class battleship was ever seriously damaged by Japanese attack. Kamikaze planes bounced off their armor. Torpedoes failed to penetrate their underwater protection systems. Long-lance torpedoes, Japan's most feared weapon, couldn't get through the anti-torpedo bulge systems. The ships were functionally invincible. Japanese naval officers couldn't understand it. How could American battleships be simultaneously so massive yet so fast? So heavily armored, yet so mechanically reliable? So precisely accurate yet capable of sustained fire rates? The answer was boring. Industrial capacity and systems engineering. America had the copper for electrical systems, had the precision machine shops for the Mark 38's gearing, had the universities producing officers who understood fire control mathematics, had the shipyards capable of building to tolerances measured in thousandths of an inch. Japan had courage and fighting spirit. America had systems engineering and industrial logistics. Courage lost. Commander Yamamoto was pulled from the water by the destroyer USS Heermann at 1935, more than 4 hours after Chokai sank. He was one of 197 survivors from the ship's crew of 850. The Americans gave him dry clothes, hot soup, and medical treatment for second-degree burns on his left arm. In the POW camp on Leyte, Yamamoto met other survivors from the Battle of Leyte Gulf. They shared stories, compared experiences, tried to understand what had happened. The consensus among them was that the Americans must have been using 3 or 4 battleships working in perfect coordination. No other explanation made sense. One ship couldn't possibly fire 9 main battery guns simultaneously without structural failure. When American interrogators told them it was a single ship, most POWs refused to believe it. "Propaganda," one destroyer captain insisted. "You're trying to demoralize us." The interrogator showed them photographs of the USS Iowa, pointed out the 3 turrets, 9 guns, all on one hull. "Impossible," the captain said. "The recoil would break the ship's back." The interrogator shrugged. "Believe what you want. Doesn't change what happened." Yamamoto believed it. He'd seen it with his own eyes, had watched the Iowa fire broadsides like a firing range target practice ship, casual and methodical, every 40 seconds, hour after hour. What he couldn't accept was how completely Japanese naval doctrine had failed. Everything he'd been taught, everything Hitomi had believed, everything 500 dead sailors had trusted, had been wrong. Not slightly wrong, catastrophically, fundamentally, fatally wrong. American engineering had made Japanese courage irrelevant. The Mark 38 gunfire control system remained classified until 1969. When the technical specifications were finally released, naval historians realized the Americans had been using computerized fire control for the entire second half of World War II. Japanese historians reviewed the documentation and came to a grim conclusion. Even if Japan had known about the Mark 38 system's existence, they lacked the industrial capacity to build a comparable version. The copper requirements alone exceeded Japan's total domestic production. The war had been decided by factors beyond courage, training, or tactical doctrine. It had been decided by electrical engineering, precision manufacturing, and systems integration. Lieutenant David Morrison left the Navy in October 1945 with the rank of lieutenant commander. He returned to Tacoma and went to work for Boeing as an electrical engineer. He helped design fuel management systems for the B-52 bomber and later worked on guidance systems for Minuteman missiles. He never opened the auto repair shop. There was no partner anymore. Morrison married in 1948, had 3 children and retired in 1978. He rarely talked about the war. When his grandchildren asked about his service, he'd show them a photograph of the USS Iowa and say, "I helped the gunners hit what they aimed at." He never mentioned the Mark 38 system, never explained how revolutionary the technology had been, never told them he'd been one of the first human beings to direct computer-controlled weapons fire in combat. Morrison died in 1994 at age 76. His obituary in the Tacoma News-Tribune was 4 sentences long and made no mention of his naval service. Commander Takeshi Yamamoto returned to Japan in 1946. He went back to his family's fishing business in Hiroshima Prefecture. The business had survived the war barely. He married his childhood sweetheart, had 2 sons, and worked as a fisherman for 43 years. In 1987, a Japanese naval historian tracked him down while researching the Battle of Leyte Gulf. Yamamoto gave a 4-hour interview describing everything he'd witnessed. The historian asked him what single moment stood out most clearly. Yamamoto didn't hesitate. "Watching the Iowa fire all 9 guns at once, I kept thinking, that's impossible. But there it was. Happening. Real." "What did that make you feel?" the historian asked. "Small," Yamamoto said. "We'd been taught that Japanese spirit could overcome material disadvantage. We believed it. Then I watched one American battleship destroy our entire formation, and I realized spirit doesn't matter if the other side has that much engineering superiority." Yamamoto died in 1992 at age 78. His obituary mentioned his fishing business and his family. It did not mention he'd been one of the few survivors to witness the full combat capability of the Iowa-class battleships. The USS Iowa was decommissioned in 1990 and is now a museum ship in Los Angeles. Her Mark 38 fire control system is still installed, though no longer operational. Visitors can walk through the plotting room where Morrison spent the war, but the rangekeeper's gears don't turn anymore, and the radar screens are dark. There's a small plaque in the fire control room listing the names of the men who served there during World War II. Morrison's name is on it, 3rd from the top, Chen's name is on a different plaque in turret 2 with a small notation. Kai 3 Nov 1944. 800,000 people visit the Iowa every year. Most of them take photos of the big guns. Very few go down to the fire control room. Almost nobody asks about the Mark 38 system. But in September 1988, something happened that would connect two old men across 44 years and 5,000 miles. The Iowa had been recommissioned in 1984 as part of President Reagan's 600-ship Navy initiative. The Mark 38 system had been replaced with modern computers, but the Navy decided to restore one section of the old fire control room for historical preservation. They needed someone who understood the original system. They called David Morrison. He was 70 years old, retired for a decade, living in a small house in Tacoma with his wife Barbara. His hands shook slightly from essential tremor, nothing serious, just age. He'd put on weight around the middle. His hair had gone completely white. The Navy's letter arrived on a Tuesday. They wanted him to consult on the restoration project, travel to Long Beach, California, spend a week helping museum staff understand how the Mark 38 actually worked in combat conditions. Barbara found him at the kitchen table, staring at the letter. "You should go," she said. "It's been 43 years, Morrison replied. "I haven't thought about that room in 43 years. That was a lie. He thought about it every November 3rd, every year, the day Chen died. "Then maybe it's time," Barbara said gently. Morrison flew to Los Angeles on October 15, 1988. A Navy lieutenant picked him up at LAX and drove him to the Long Beach Naval Station. The Iowa was docked at Pier 7, looking exactly as he remembered, massive, gray, impossibly solid. They gave him a hard hat and a visitor badge, led him down familiar corridors that smelled like paint and metal. The fire control room was 3 decks down, exactly where it had been. The moment Morrison stepped through the hatch, he was 26 again. The Mark 8 rangekeeper sat in the center of the compartment, partially disassembled. The mechanical calculating drums were exposed, showing the precision gears and cams that had once computed ballistic solutions 30 times per second. Museum staff had been trying to understand the system's operation, but the technical manuals used 1940s engineering terminology that modern computer programmers couldn't pass. "Mr. Morrison," the museum director said, "we're trying to create an interactive display that shows visitors how this system worked, but we're struggling with some of the operational sequences." Morrison walked to the rangekeeper, put his hand on one of the input drums. The metal was cold and smooth. "This drum receives target bearing from the radar," he said quietly. "It rotates this cam, which adjusts this gear train, which feeds into the elevation calculator here." His hands remembered, moved from component to component, tracing signal paths that he hadn't thought about in 4 decades. When you got a firing solution, this indicator light would illuminate, green for valid solution, red for out-of-range target. The rangekeeper would update continuously, every 2-7 seconds, new solution, new firing data sent to the turrets. The museum staff took notes, asked questions. Morrison answered them all, his memory crystal clear now, everything coming back. They worked for 6 hours that first day. Morrison explained the radar integration, the ballistic computer's wind compensation algorithms, the gyroscopic stable vertical reference that compensated for ship motion. He drew diagrams, described combat operations, made the dead machine come alive again with memories. On the 3rd day, a Japanese visitor arrived at the museum. The museum director introduced him. "Mr. Morrison, this is Mr. Takeshi Yamamoto. He's visiting from Hiroshima. He's a survivor of the Battle of Leyte Gulf. When he heard we had the original fire control officer here, he asked if he could meet you." Yamamoto was 70 years old, slight and thin, wearing a simple gray suit. He spoke excellent English with a careful, precise accent. "Lieutenant Commander Morrison," Yamamoto said, bowing slightly, "I served on the cruiser Chokai. I was in the water when your ship fired on our formation. I watched you sink 5 ships in 2 hours." Morrison felt his chest tighten. "I'm sorry for your loss." "I'm not here for apology," Yamamoto said. "I'm here because I have carried a question for 44 years. How did one ship fire 9 guns at once? Japanese officers told us it was impossible. Even in POW camp, we didn't believe it was one ship." Morrison looked at the rangekeeper, Then back at Yamamoto. "Would you like to understand how it worked?" Morrison asked. Yamamoto's eyes widened. "Very much, yes." For the next 2 hours, Morrison walked Yamamoto through the Mark 38 system, explained how the analog computer integrated multiple data streams, showed him the radar ranging system, the ballistic calculator, the turret control interfaces, described how American industrial capacity made it possible to build systems that Japanese shipyards couldn't replicate. Yamamoto listened intently, occasionally asking technical questions that revealed his own deep understanding of naval gunnery. "The training time for radar operators?" Yamamoto asked. 12 weeks intensive school," Morrison replied. "Then 6 months shipboard qualification." "And the rangekeeper maintenance?" "Daily calibration. Weekly precision gear inspection. We had 2 full-time technicians just for this one system." Yamamoto shook his head slowly. "We had 1 rangefinder technician for the entire ship, and he also maintained the radio equipment." "Different industrial philosophies," Morrison said. "We had the resources to specialize, to build redundancy into every system." They stood in silence for a moment, 2 old men in a museum, surrounded by technology that had once determined who lived and who died. "I lost my best friend on the Chokai," Yamamoto said quietly. "Captain Hitomi Soichiro. He had 2 daughters." Morrison felt something crack inside his chest. "I lost mine too." Chief Petty Officer James Chen. Kamikaze attack November 3, 1944. "We were supposed to open a garage together after the war." Yamamoto looked at Morrison for a long moment. Then he reached out his hand. Morrison took it. "The war took our friends," Yamamoto said, "but we survived. That must mean something." "I don't know what it means," Morrison admitted. "I've been trying to figure that out for 44 years. "Perhaps it means we remember them," Yamamoto suggested. "We tell their stories. We make sure they're not forgotten." Morrison thought about Chen, about the handshake in boot camp, about the auto shop they'd never opened. "Yeah," Morrison said, "maybe that's enough." The museum director took a photograph of them, 2 elderly men shaking hands in front of the Mark 38 rangekeeper. Morrison in a Boeing windbreaker, Yamamoto in his grey suit, both of them looking tired and sad, and somehow peaceful. That photograph now hangs in the Iowa Museum's fire control room, with a small caption: "Former adversaries Lotun Sidiar, David Morrison, USN, and Sea Dr. Takeshi Yamamoto, IJN, meet aboard USS Iowa, October 1988. Morrison operated the Mark 38 fire control system during the Battle of Leyte Gulf. Yamamoto survived the sinking of IJN Chokai during the same battle. Before Yamamoto left that day, he asked Morrison one final question. Do you think the system was worth it? All that engineering, all that precision, all those lives?" Morrison looked at the rangekeeper, thought about what it represented, the thousands of engineers who'd designed it, the factory workers who'd built it, the sailors who'd maintained it, the targets it had destroyed. "I think it was inevitable," Morrison said finally. "Once we understood that mathematics could be weaponized, someone was going to build it. Better that we built it first than the other way around." "But do you think it was worth it?" Yamamoto pressed. Morrison met his eyes. "I think it ended the war faster. I think it saved American lives. I think it killed a lot of people like your friend Hitomi. And I think I'll never know if the mathematics adds up to something morally defensible." Yamamoto nodded slowly. "An honest answer. Thank you." They shook hands one more time. Yamamoto flew back to Japan the next day. Morrison finished his consultation work and returned to Tacoma. They exchanged letters twice a year for the next 6 years, awkward formal letters that gradually became warmer. Morrison sent photos of his grandchildren. Yamamoto sent pictures of his fishing boats. Neither of them ever fully resolved the moral weight of what had happened in October 1944. But they carried it together, across language and culture and history. 2 old men who'd been on opposite sides of 9/2, 700-pound shells traveling at 690 feet per second. Yamamoto died in 1992. Morrison received a letter from Yamamoto's son, written in careful English. "My father asked me to tell you that meeting you gave him peace. He stopped having nightmares about the battle after 1988. He said you helped him understand that the war wasn't about honor or courage. It was about mathematics and resources. That made it easier to accept. Morrison kept that letter in his desk drawer until his own death in 1994. The revolution in naval combat wasn't dramatic. It was mathematical. 9 guns firing simultaneously because a 500-pound analog computer could calculate ballistic solutions faster than human brains. The future of warfare delivered in 2 700-pound increments every 40 seconds with inhuman precision. Commander Yamamoto was right about one thing. Watching it happen made you feel small, because courage and training and tactical brilliance all became irrelevant the moment one side showed up with weaponized mathematics and the industrial capacity to build it at scale. But perhaps Morrison and Yamamoto discovered something else, that even in the mathematics of destruction, there was room for 2 old enemies to find common ground in shared loss, shared memory, and shared humanity. If this story moved you, hit that like button. These stories of technological revolution and human cost need to be remembered. Subscribe to this channel so you never miss another forgotten story from World War II. Drop a comment telling us, what do you think was the most important technological advantage of World War II? Was it radar, code breaking, the atomic bomb, or something like the Iowa's fire control system that changed everything quietly? Thank you for keeping these memories alive. These men, Morrison, Chen, Yamamoto, Hitomi, they're gone now, but their stories matter, and you're the reason they won't be forgotten.